So a lot of times they won't give you any more information rather than a couple of statements with information. And you'll have to create your own two-way table. And if they create the two-way table for you, a lot of times they'll leave out your total column. So it'll just be this part, and you have to add in your total columns. So let's look at just filling in a table in general so that we can feel a little bit more comfortable with that. And then we'll look at some associated questions and more examples. So this first example says, during 1 month, exactly half of the 180 babies born in a hospital were boys, and 40 babies weighed, it says weight, but it should say weighed 8 pounds or more. There were 26 baby boys who weighed 8 pounds or more. So they're giving me this information. They're giving me information about boy versus girl, and they're giving me information about being less than 8 pounds or 8 pounds and more. They're also telling me how many total babies were born. So let's fill in that information that they gave me directly. So they told me exactly half of the 180 babies born in the hospital. So that's our first number, 180 babies. I know that exactly half were boys, which means that the other half had to be girls. I also know that 40 babies weighed 8 pounds or more. So of our babies, the total of them, it doesn't say boy babies or girl babies, of the total babies, 40 of them weighed 8 pounds or more. And then the last bit of information that I am given is that 26 of the baby boys weighed 8 pounds or more. So we have baby boys who weighed 8 pounds or more. There are 26 of them. So I'm going to find boys. I'm going to find weighed 8 pounds or more. And that's where that 26 is going. So that's how we got those numbers we have in the table already. Now what I'm going to need to do is work backwards to fill in the rest of this table. So if I have this total of 40 and I know that 26 were boys, that is telling me that 14 were girls because 26 plus 14 is 40. I can also work in this reverse direction by doing 90 minus 26 and I get 64. So 64 babies were boys that weighed less than 8 pounds. And then working in my reverse direction here, I know that 76 of the babies born were girls that weighed less than 8 pounds. And I can either do 180 minus 40 to get my 140 total, or I could have just added straight down to get 140. So we filled in our entire two-way table. That's our first step that we needed to do in order to address these problems. So the first problem that they gave me says, what is the relative frequency of baby girls who weighed 8 pounds or more? So what we need to keep in mind when we are looking at relative frequency is that sometimes the total that they want you to compare because it's relative, what it's relative to isn't always our total. More often than not, the total that they want you to compare to comes after the word of. So our word of is our key word. And what comes after it tells me what we are looking at as the whole. So if baby girls is the whole, so we're only looking in this row, we know that this is our whole. What is the relative frequency of those 90 girls that weighed 8 pounds or more? So instead of using this 180 as our denominator, 90 is our denominator, because we're just trying to figure out what portion of 90 is 14. So I'm going to do 14 divided by 90. So the relative frequency of the baby girls that weighed 8 pounds or more is 0.156. So that is telling me that 0.156 of every baby girl weighed 8 pounds or more. That doesn't really work because you can't have part of a baby weighing that much, but nonetheless, that's how we're trying to explain it. If you multiply this by 100%, it makes a little bit more sense. That gives me 15.6%, which is just telling me that of the baby girls born in the hospital, 15.6% of them weighed 8 pounds or more. The next problem is a percentage one. So what percentage of baby boys weighed 8 pounds or more? So this time of is still my keyword, but it's telling me we're looking at baby boys as the total. And then the boys who weighed 8 pounds or more as the part. So we've got 90 total boys and 26 that weighed 8 pounds or more. That'll give me my relative frequency. And then once I know this relative frequency, I can multiply by 100% to get the percent. So 28.9% of the boys born in the hospital weighed 8 pounds or more. The next question says what percentage of babies born were girls? So again, we're just using our keyword of. This is asking me about the total. So of the babies born, how many or what percentage were girls? We actually got this information in the text because they told me half of the babies are boys, which means half are girls, which means 50% are girls. But if I couldn't do that reasoning myself, we know we're looking for girls in relation to the total babies. So I'm going to do 90 over 180. That gives me 0.5. I'm going to multiply by 100% because we want a percentage, and I get 50%. So hopefully that helped us think about two-way tables as, a specific example problem, but we can also have problems that look more like this. So this one says complete the two-way table for 9th graders school transportation survey. So they gave us a lot of information. We need to complete this table. This table is still a two-way table, but what's happening is we're surveying males and females, and they're one of those categories, and they're telling us that their transportation to school is walk or car or bus or bike. You can only fall into one of those categories. So let's think about what we have so far in this problem, and we can fill in the missing numbers. So I want to look for slots, either columns that are only missing 1 point or rows that are only missing 1 spot. So this one's one that stands out to me. I can do 45 minus 28, and I get 17, and then I can keep going. So these problems are almost always calculator active, so use your calculator. We can fill in this row. That's 15 because 15 plus 12 is 27. I'm going to do 69 minus 17 to get 52. Remember, I'm just looking for rows and columns where I'm only missing one number. I can't fill in this one using this column yet, but I can go that way. So let's do 129 minus 52 minus 15 minus 28 to see what this one is. And then I can either add across to get my total. Or I can add across to get this total. 129 plus 92 is 221. And then I'm going to add across this way and do 34 plus 46. So there are a lot of numbers here. I can check all my rows and columns by adding up and making sure they are their totals, but hopefully that part we feel comfortable with. So let's look at the problems. This first problem says, what percent of 9th grade girls walk to school? There's our key word, of. Of the 9th grade girls, so that is my total. So I'm just going to look on this chart for the total number of girls that I have. What percentage walk to school? So this is my whole. I'm looking for females who walk as the part. So it's going to be 46 over 92. Once I figure out that relative frequency, I'm going to multiply by 100 to get my percent. So 50% of the girls walk to school. The next question says, what percent of 9th graders are girls who walk to school? So this one is a really good one to look at because this is asking our keyword of. So of 9th graders. So this number, our total 9th graders, is now our denominator. It's now our whole. What percentage of those are girls who walk to school? So not only do they have to be female, but they have to also walk to school. So my part is the same because my part is still females who walk to school. But now I'm looking at that in relation to the total number of 9th graders. So I'm going to do 46 divided by 221, and I get 0.208. I'm going to multiply by 100% because it's asking for a percentage. And I'm going to get 20.8%. So of the 9th graders, almost 21% are women who walk to school. The next question says, what percent of students ride the bus? So again, our keyword is of students. That's the same total we were working with before. It's the total students. It's not telling me one specific category. So I know my denominator is going to be 221. Students that ride the bus. So my part is going to be those who ride the bus, not women or men, just the students that ride the bus. So that's 27. So I'm going to do 27 divided by 221, and I get 0.122. This is asking for a percentage, so we're going to multiply by 100%, and I'm going to get 12.2%. So of the students, about 12% ride the bus. And this last question is going to be solved the exact same way. What percent of boys ride their bike? Of is our keyword. They're saying boys, and then the part is the boys who ride their bike. So our total is our total number of boys, which is 129. And our part is those boys who ride their bike. I'm going to find my relative frequency by doing division. And then I'm going to multiply by 100% to get my percent.